So let's have a look once again, a detailed look at this unit and process of measurement. In case if we are measuring length and I am taking 1 meter as standard of measurement, I call it a unit. So I can say the quantities used as standard of measurement is called unit. So for length, maybe if I am taking 1 meter as a standard of measurement, it means 1 meter is the unit that I have taken. So for measurement, the very first thing we have to decide is the standard of measurement. Maybe for measurement of mass, 1 kg is standard of measurement. So I'll call it unit. This is unit of length. This is standard of measurement of length. 1 kg is the unit of mass. This is standard of measurement of mass. 1 second is unit of time. It is standard of measurement of time. So the very first thing is that standard of measurement that we choose, we call it a unit. Now, in case if I am saying how a quantity would be represented. So a quantity will be represented as N into U, that I have already said before. N is the unit, U is the unit, and N is number of times the unit is repeated, numeric value. For example, quantity is 4 meter. It means the numeric value is 4 and the standard unit is 1 meter. In other situation, when I take unit as centimeter, the same value would come out to be 400 centimeter. Here, the numeric value is changed 400, where the unit is changed centimeter. So for the same physical quantity, I can take another unit also, and in that case numeric value will change. So I can say in one system Q is equal to N1 U1, unit is U1, say 1 meter, and numeric value is 4 meter. In other system of unit, same value is N2 U2. U2 is another unit centimeter and N2 is another numeric value, like here. The value remain the same, quantity remain the same, N1 U1 is equal to N2 U2. So we can finally say N1 U1 is equal to N2 U2, like that. If we are taking two different units to measure the same physical quantity, I can say yes, in two different units the numeric value will be different. Yes, the value of quantity remains the same, physical quantity remains the same. Now here is one example in front of you. Here in this arrangement, inches are on this side on the scale and centimeter are on this side of the scale. For measuring this pencil, length of the pencil, it is repeated 8 times. It comes out to be 8 times of 1 centimeter. So here the quantity is 8 centimeter. The unit is 1 centimeter and numeric value is 8. I hope you have understood. The basic formula for measurement of physical quantity is N into U. You have to choose a standard unit and then you will have to see how many times that unit is repeated. Now here you must have sensed that we have got different system of units. Like if I talk about different system of unit, FPS system. Now in FPS system, the unit of length is feet, the unit of mass is pounds, the unit of time is second. We have CGS system. Here the unit of length is centimeter, the unit of mass is gram, and the unit of time is second. We have MKS system. Here the unit of mass is, unit of length is meter, the unit of mass is kilogram, the unit of time is second. We have finally, now there is a confusion, which system is to be used in which situation. So point is very clear. I cannot use kilometer for measuring as a standard unit for measuring the length of a pencil. I will use kilometer for measuring the length between two cities, the gap between two cities. I will use 1 meter for measuring the length of a cloth, but I may use centimeter for measuring the length of a pencil or any small thing, small object. And for very small object, I can use millimeter as well as centimeter as well as micrometer. So here, as per the requirement, we can go for different systems. But yes, to minimize that confusion, we have SI system, which is now international system or system international, universally acceptable for all engineers and scientists across the world as a standard system. And this SI system is just an extended version of MKS system. Like MKS system just talks about 3 units, it has got 7 fundamental units. We will talk about the SI system in detail. So it's basically MKS system extended, and it is used as a most standard system across the world. Now moving ahead, just to give you some more idea about the different units, for example in length, different abbreviations. For example in length, the standard unit can be 1 meter. Then comes 1 decimeter. So 1 decimeter. That comes out to be 10 to the power minus 1 meter. 1 centimeter. I am removing this. 1 centimeter. That is 10 to the power minus 2 meter. 1 millimeter. That is 10 to the power minus 3 meter. Then goes 1 decameter. That is 10 to the power 1 meter. 1 hectometer. You must have studied in earlier classes, 10 to the power 2 meter. 1 kilometer. So abbreviations matter, 10 to the power 3 meter, and like that. Similarly, talk in mass. There is 1 gram at the center. 1 decigram. 10 to the power minus 1 gram. 1 centigram. 10 to the power minus 2 gram. 1 milligram. 10 to the power minus 3 gram. Then 1 decagram. 10 to the power 1 gram. 1 hectogram. 10 to the power 2 gram. 1 kilogram will be 10 to the power 3 gram. So this is how we use all these abbreviations. Similarly, relation between different units of capacity, like 1 liter will be equal to 10 to the power 3 milliliter. And similarly, 1 kiloliter will be 10 to the power 3 liters. So this, once you are sure, kilo, it means 10 to the power 3, milli, that is 10 to the power minus 3. So that's how you will always compare, you will always relate between bigger and smaller units. Now, a comparison between the fundamental quantity and fundamental units and derived physical quantity and derived units. There are some most fundamental physical quantities which cannot be further defined in terms of each other. For example, talk of length. Length is a fundamental physical quantity. Mass is a fundamental physical quantity. Time is a fundamental physical quantity. Temperature, electric current, amount of substance, and luminous intensity, or for the light, which is used for the intensity of light, the brightness of the light. They are all considered in SI system as 7 fundamental physical quantities, and they cannot be further defined. They cannot be defined in terms of each other. They are the most fundamental physical quantities. Like the units that are decided for them in SI system, for length, meter is a fundamental unit, for mass, kilogram, for time, second, for temperature, Kelvin, for electric current, ampere, for amount of substance, mole, and for light intensity, candela. So these are the 7 fundamental units that are decided, and they cannot be described in terms of each other or further described. So when we talk about the fundamental units, they are those units which are independent of any other among those 7. So length has nothing to do with mass, time, temperature, etc. Similarly, mass has nothing to do with length, time, temperature, etc. Similarly, electric current has nothing to do with length, mass, and time. They are the 7 fundamental units. They cannot be described further in terms of each other. And they cannot be reduced to elementary level. So you cannot further break it, that it is made up of something else. Only 7 fundamental units exist in metric system or SI system. As I said earlier, in SI system, an SI system is an extended version of MK system and has got 7 fundamental units. So these 7 fundamental units are meter, kilogram, second, Kelvin for temperature, mole for amount of matter, ampere for electric current, and candela for luminous intensity or the amount of visible light. And then comes the derived units. Derived units are all those numerous units for numerous different physical quantities that we come across. They are all derived using 7 fundamental units. For example, talk of area. So area includes length into breadth. For length, the unit is meter. For breadth, the unit is meter. So its unit is meter square. Think of volume. It is length into breadth into height. So it is meter into meter into meter. So it is meter cube. Think of density. They are all derived using those fundamental units, which is mass over volume. So it is kilogram per meter cube, mass per unit volume. They are all derived units. There are 7 fundamental units, and using them you are deriving them, just combining them. So derived units are all those units which are obtained by multiplying and dividing one or more fundamental units with or without introducing any other numerical value. So it is not necessary that you are saying density is 10 kilogram per meter cube. Just by multiplying or dividing these fundamental units, you are getting these derived units. Derived unit can be reduced to its elementary. You can further break it. You can write kilogram per meter cube, kilogram divided by meter into meter into meter. There exist a large number of derived units. So as I said, as we move ahead in different part of physics, we will come across numerous derived units. But remember, all those numerous will be produced using these 7 fundamental units only. And then these are some examples like Newton, force, unit of force. So unit of force is mass into acceleration, so it is kilogram meter per second square. So that's how we have the different derived units. Joule, unit of work, unit of energy, it is kilogram. So if you are talking of 1 joule, it is 1 kilogram. It is force into distance, meter square per second square, like this. So we have all those derived units derived using fundamental units. Now moving further, here we are trying to once again come to this talk of velocity. Velocity is what? Distance per unit time. This is a derived unit. So distance meter for time second. So I can say it is meter per second. If we talk of acceleration, it is change in velocity per unit time. So it is meter per second minus meter per second divided by second. So it comes out to be meter per second square. We talk of derived unit of force, which is mass into acceleration. So it is kilogram meter per second square. We talk of derived unit of work that we have just written, joule. So it is force into distance. So it is kilogram meter square per second square. So that's how we have got all derived units. They are derived using the fundamental units. So we should remember that those physical quantities or those units which cannot be further described, they are fundamental units. There are 7 fundamental physical quantity and fundamental units. They are length, mass, time, temperature, luminous intensity, amount of matter, and comes the current, electric current. And then all other units in physics, they are derived using them.